flame contamination detectors, they are sensors that will detect a certain level of sodium. Why sodium? Because sodium will produce a certain light of a certain color. Probably know metals, when they burn and they oxidize, they produce a certain type of flame. And this flame has a color that could be detected by these sensors. That will indicate, how the fuel, if it's fuel, it's contaminated with sodium, and under this condition in here, and what is the quality of the burning under the provision. This is the sensor. It has an optical fiber. The same thing. This optical fiber is sapphire that goes into plugs into the burner in the combustor.
These are probably used in land-based turbines, right?
I assume that it's used in land. It's not in.
And for ship applications, they have a problem with fuel.
The fuel quality, right?
Because they need to get fuel from everywhere.
Now, finally, summary of the current technologies. We just discuss here what is the state of the art, what is more or less available today on the market. What is important here is the fact that the sensors that are available right now, they are most of them limited to this, strange range, minus 65 to plus 115 centigrade. There is a need of sensors, and these sensors, unfortunately, they have very peculiar requirements, especially operating temperature. And given the location of these sensors, what we figure out in here is that 500 degrees will do it. At least at this stage of development, probably we would advance more in knowing what happens in the engine, and probably being able to apply these technologies in the engine with sensors with the capability of operating at 500 degrees. So there are sensors available, but only on paper. You'll find lots of research papers on measurement or on sensors. It's standard journals on such matter. And they present, either approaches or some results, experimental results made, sensors made on the knee. They could do, certain, to a certain extent of the job, but they are not definitely suitable for aerospace applications. And technology is definitely way too far. We'll discuss tomorrow morning how far this technology is when we look at the roadmap. Some of the sensors would make possible indirect measurements and matching to the model. The more capability of going to higher temperature you have, probably the model will be more accurate. We, in the conclusion here, I think more than sensor, we need new principle of measurement. So yeah, still, if you look at pressure, we measure like that for 300 years. It's the same way of measuring pressure. It's like building roads. 2,500 years, same road. Nothing has changed, right? So tomorrow we'll discuss the rest of the lecture. What happens, I just want to acknowledge the fact that the organizer is not here because he has a business. He went to Canada. However, I want to thank him, if you agree with me, for the lunch that he organized today. It's very nice of him. Tomorrow we don't have any lunch. On the other hand, if we have a website where the report is available. I know that if you want the report, you probably get it now. You'll go home, you'll forget about it, and this. If you want the report, we could email you the link to the website. Yeah. Unfortunately, we don't have internet.
In the presentation, there's the link is listed in the presentation.
It's in presentation, right. So, if you, my suggestion is, if you have access to the internet, just download it now, because again, going home, you'll forget about it. I do the same thing.
This is on questions.